Hello everyone, I'm posting my second task given by the Spark Foundation. This is about the prediction using unsupervised machine learning, and prediction is all about the optimum number of clusters and representing them visually. I'm using tool Python, and I'm importing the necessary libraries. uh, I'm importing pandas for data handling, numpy for number handling, and from sklearn.clusters import k-means for the making of the clusters. From sklearn.preprocessing import label encoder to give the label to the clusters. And for the visualization part, I'm using importing seaborn matplotlib and person matplotlib inline to see the graphical visualization in notebook itself. So we have read the data as usual using pd.read csv, and we are checking the data also. There are five columns in the data, and we are checking the shape of the data. There are 150 rows and 5 columns, and we are checking the info of the data also. There are non-null values, so data is clean. Now we will check the summary of the data. This is the summary of the data, and we can clearly see that all the values are on the different magnitude. So we have to scale the data first for making the clusters. We will see the duplicates also in the data. So there are no duplicates in the data set itself. So now we will scale the data. For this, we will import the standard scaler from the package c sklearn.preprocessing. Now we will store this standard scalar in a object called x, and now we will scale the data and we will store it in a scaled df object, and we will fit that standard scalar and transform the data, and we will log the data from first column to fourth column. Now this is our scaled data. Now we will create the cluster using k-means, and we will first start with the two clusters, and uh, we will create k-means cluster and store the result in the object k-means. And now we will fit k-means on the scaled df, and now we will see the output for all the clusters, because we have the two clusters only, so it has the two labels 0 and 1. Now we will see the inertia. Inertia is the within clusters distance. So this is for the two clusters 222, and now we are going for the three cluster. This is 139.820. This means this is reducing significantly from two clusters to three clusters. Now we will check for the four clusters. That is also reducing, but not that significantly as it is reducing from 2 to 3 clusters. So it is 114.304 for 4 clusters. So WSS reduces as K keeps increasing. Now we will calculate WSS for other values of K also. So now we will see, now we will create an empty object WSS, and we will run a loop, for loop for this, and we will pass the values from 1 to 10 for the clusters, and we will fit these clusters in a scaled data, and it will give the inertia values, and these values we will be storing in WSS object here. So all the inertia values which will come from this for loop, it will be stored in this WSS. So now we will see this WSS inertia values, and now we can see manually also that from 1 to 2, 2 to 3, and 3 to 4, this is reducing the inertia value. This is, and we can manually also see that 2 to 3 clusters is a significant reduce in the inertia value. So we can say that 3 clusters are the optimum clusters for these data sets, and we can see it from the visualization itself also, this is an elbow. So why this is called an elbow graph? We can see clearly that there is a shape of elbow going. uh, so we can see that there are from 1 to 2 and 2 to 3 there is a significant reduce in the inertia values. So we can see that 3 clusters are the optimum number of clusters for the data set. Now visualization of clusters also, we can see the clusters, how the clusters are mapped from the centroids. So we can clearly see that there are three number of clusters, and these are the centroids of the clusters. And we can see within sum of square is uh, very less within the cluster. So they are correctly mapped. So so this is how we saw the visualization of the cluster itself, and they are correctly mapped from their centroids. And now the evaluation, cluster evaluation for three clusters. Now we have taken the we have decided the like number of clusters are three. So we will evaluate how correct it is. So there is a Saluti score called. So Saluti score should be on the positive side. So uh, for from this we can say that our clusters are rightly mapped. So from the three clusters, we have this Illustrator score 4593.4593, and we will go on and see for the k is equal to 4. So this is again the Illustrator score for the four clusters are 3.3865. So this is we can say that this score is better than the four clusters. So we can say that Saluti score is better for three clusters than for four clusters. So final clusters will be 3. So we can append this clusters column to the data set itself. So here we can append the this here we can append this column cluster k means 3 is equal to labels, and we can check the head also to see whether it is correctly appended or not, and these are our clusters. So conclusion is the optimum number of clusters for the data sets are 3. Thank you.